So 9 was kind of a fun one. If you notice, not this one. Okay, that's the other one. That one's not fun. But here's the derivative. Here it is. After you took the derivative, here it is all simplified. And then the value is 8/9. 10. Look at all this good stuff right here. Here it is. Here's the derivative all simplified with the value of 27/32. And again, if you're plugging in a value, it's kind of like, why do all the simplification with the algebra? You know what I'm saying? If you're just going to plug in a value anyways. Do you know what I'm saying, Jessica? Because you have to plug it into something, where this one kind of takes extra work and then plug it. It just kind of depends how you look at it. All right, 11 skip, 12 skip, 13. Again, two different ways you can look at it. You can do product rule, or you can first multiply it out and then do the power rule. Okay? Where is it? Here you go. Here's multiplying it out first, and then just doing that. And usually, it's just easier. If you can just do power rule, it's just making the problem easier on you. Does that make sense? Am I going too fast? How are we feeling? Good pace? Too slow? Okay. All right. So here's 14. Again, you can multiply it out. This one would be, again, easier multiplying it out if you did that first. But either way, you get a derivative of 6x plus 1. 15, it's in, or 15 is right here. Here you go. Here's after you took the derivative, it looks like this. Again, the derivative of the denominator is 1. The derivative of x is 1. And here it is all simplified. You get the same in either case. So here's something that, to look out for. So on that top, it's a difference of squares. X squared minus 1. Or t squared minus 1. That simplifies to t plus 1, t minus 1. So if you do that, you can cancel that out to begin with. So you don't have to do a quotient rule anymore. You just take the derivative of t plus 1, which is just 1. Now just keep in mind, Amina, keep in mind that you still can't take the derivative, even though the derivative function is t plus 1, you can't take the derivative at 1 still. You know what I'm saying? Because that doesn't exist in the original function. So taking the derivative at 1 wouldn't make sense. Even though it's true, you could do it in this little guy. Chris, does that make sense? Okay. Things to look at, things to keep in mind. Anything that could, make it easier on you. Okay, 17, same thing. You can multiply it out first, or not, but either way you take the derivative, and you get, what do you get, this? Yeah, there it is right there. Or this right here. So there it is not multiplied out, there it is multiplied out. 18, don't worry about. 19, if you do the quotient rule, again, the derivative of 1 is what? Be careful with that. Some people will still put the 1. The derivative of the constant is 0. You can treat this as a quotient rule, but the derivative of the numerator is going to be 0. And the derivative of the denominator of x plus 4 is 1. Okay? So you wind up like this. Now I hate when books and things write it with that negative in front. What that's really saying is, negative 1 over x plus 4 squared. Does that make sense, David? I hate writing it like that. I hate that books do that, but that's what it means. And you get negative 1 over 36. 20. Here it is, after you take the derivative. Here it is simplified, and just look again, they didn't multiply out the denominator, they just did the numerator, and then you plug in a value and you get 0 there. 21, this was a fun one, yes? If you multiplied it out, it's actually a pretty easy problem. That's what we're going to do together. You can do product rule, and it's a big hot mess. And it's like, hey, look, it equals 1. How did that happen? Well, if you multiply it out first, you'll see why. Again, it's just be comfortable with your exponent laws. Either way, it's x plus 1 and the derivative is 1. 22. There's your derivative right here. 23 is negative 80. Here's your derivative. There it is all simplified. There it is right here all multiplied out. But at 2, there's your derivative. 24, skip. 25. Here it is. Again, derivative of 1 is 0. Here it is all simplified. And you get a value of negative 3/4. 26, you could do some simplification with the algebra. I think this is one that we're going to do together. In either case, here's your derivative, and then here it is all simplified. Okay. 27, this looked like this was a nice hot mess. There's lots of stuff, but it's the same rules. And what the goal of the last two assignments is get comfortable with these rules. The sooner you do, it's just you're going to make your life easier. You don't have to worry about the quotient rule, remembering what it was. You just do the quotient rule, and then now we're going to worry about the application. How do we figure out what they're asking? What are we supposed to do with this derivative? Does that make sense, Marco? So the sooner you get comfortable with this, just the easier your life's going to be. Okay, 26 or 28. There's your derivative right here. 29, and they pull this junk all the time. 29, 3 to the 1/2 times 5 to the 1/2. That's just a number. Do you know what I'm saying, Estella? So the derivative of this number is 0. That's all just a number. There's no x, there's no variable, it's just a number. And the same thing they try to pull that tomfoolery with a pi squared. Here's pi squared times x minus 1. Well, pi squared is just a number. It's, it's 6 point or 9 point something. So the derivative of that is 0. And is that it? Was that all of them? Yeah? Okay. So take a couple minutes, take like 5, 4, check through anything you missed. Okay.
I just did the whole thing, and then I put it all over.
Right up this thing right there. See right there.
It's really long though.
Yes, and that's why we're doing it. Keep doing it. No. Oh, yeah. Were you with Okay. Talk about meet me after we figure that out.
Oh no, no. What I meant was just
Okay.